The topic of today's class is electronic configuration, fundamentals, Pauling diagram, and Hunds Rule. The class outline. In today's class, we're going to learn electronic configuration definition, tools needed to perform the electronic configuration, and how to draw a Pauling energy diagram by yourself. So, electronic configuration. The purpose of the electronic configuration is to put the electrons in the available orbitals on each shell. The electrons are placed into the least energetic orbital available for that particular shell. By doing that, we are producing the most stable configurations, or the least energetic configuration, which is called ground state electronic configuration. To perform the electronic distribution, you need some tools. They are, first, definitely you're going to need a periodic table. Then, you're going to need a Pauling energy diagram, which you're going to learn how to draw by yourself on this video. And finally, you have to respect the Hunds Rule, which is called also as off-ball principle. Okay? So the periodic table, we are all familiar with that. So basically, the periodic table, it brings the atomic number on that. Okay? And taking the oxygen as an example, so the oxygen here we can observe has atomic number equals 8. The atomic number Z equals 8 means that the oxygen has 8 protons, and as oxygen is a neutral atom and not an ion, so it also has 8 electrons. Next, our next tool needed to perform electronic distribution is the Pauling energy diagram, as you can see over here. So why is that diagram very necessary? Because it shows the relative energy of each group of orbital on each shell, okay, on each shell, and the relative energy of each shell as well. So it shows like the lowest group of orbital available in that moment. So basically it tells us, okay, place your next electron on this group of orbital. That's the purpose and the usefulness of the Pauling energy diagram. The Pauling energy diagram is so necessary and important to do the electronic distribution properly, but not always it's provided by your instructor on your test, on your assignment. So it's really important that you learn how to draw the diagram by yourself, which is very possible. So let's do in a very step-by-step way. So you can pause the video, you can try by yourself, you can complete, you can do as many times as you need and get familiar with that. Okay? So first of all, you write the numbers on 7 rows on your notebook or your tablet, whatever you're gonna drawing. You put like numbers from 1 to 7, starting from top to bottom, okay? And then after that, you place on the right of each number the small letter S with the superscript 2, okay? Basically, this S tells that we are using first the group of S orbitals for each shell. Then, for the second shell, you put a 2p, superscript 6 as well. Then, for the third shell, you put a 3p6 and a 3d10 group of orbital. For the 4, you put also a 4p6, a 4d10, and a 4f14. For the fifth, you repeat the same you did on the fourth, okay? So 5p6, 5d10, and 5f14. Then we start to decrease, okay? So we had 3 groups of orbital in the fifth. Now in the sixth, you're gonna have a total of like 3 groups of orbital. So you put like 6p6, 6d10, and you keep decreasing the 7. So 7p6, okay? At this point, you have like inserted like all possible and relevant groups of orbital on each shell, okay? So the last step on drawing your diagram is to draw the arrows. The arrows always will be drawn from top to bottom, okay? Why? Because the lowest energetic shell is the n equals 1. and the highest energetic is n equals 7. So put the arrow there, okay, in the 1s2. Then you put the 2s2, okay, the following arrow, and then you put in 2p6 3s2. Next, you're gonna put on 3p6 4s2. Then if you still have electrons to be placed, the next electrons will go through 3d10 4p6 5s2. Then the next arrow trespass 4d10 5p6 6s2. Then another arrow that starts on 4f14 5d10 6p6 7s2. And the last arrow passing through 5f14 6d10 7p6. Okay, so you read the diagram, you fill up the electrons from top to bottom and from tail to head of each arrow. Okay, so the first 2 electrons you have, they will be placed in the 1s2. The next 2 electrons in the 2s. Okay, if you still have electrons, then you put them preferentially in the 2p, and then 3s, and then 3p, 4s, 3d, 4p, 5s, until you distribute all electrons, okay? Remind, always read the diagram from top to bottom, okay? And from tail to head for each arrow. You're gonna have a lot of examples actually, okay, how to use the diagram, but in the next video, okay? So that won't be on this video specifically, so that won't be too big, okay, for you to watch. But you're very welcome to stop the video, pause, go back and forth, try by yourself, okay? I'm pretty sure if you try it a couple of times, you'll be able to get it done, okay? And get it done correctly on your test, okay? So the next tool we need to properly do the electronic distribution is to respect the Hunds rule, okay? Basically, the Hunds rule, it says that for a set of individual orbitals with the same energy, okay, the electrons should be distributed as unpaired as possible, okay? So an example, distribute the 4 electrons in a set of 3p orbitals. So we separated here 2 possible ways we can do that. Let's do first the solution 1. In the solution 1, the first electron goes unpaired in a first individual orbital. Okay, then the next electron goes also unpaired in a second individual orbital, and then the third electron goes unpaired in a third individual orbital. We have a 4th electron to be distributed, so it goes paired in the first individual orbital. So basically, the 4 electrons were distributed onto the set of 3p orbitals, which comprises 3 individual p-type orbitals. Now let's see the second solution. In the second solution, the electron comes unpaired in the first individual p orbital. Then the second electron is put paired in the same individual orbital. Then the third electron goes unpaired in the second individual orbital. Then the 4th electron goes paired in the second individual orbital. Between those 2 solutions, definitely the solution that respects the Hunds rule is the solution 1. The solution is correct, okay? Why? Because it has the highest number of unpaired electrons in that group of individual orbitals of the same energy, okay? So just to not be long on this video, so I'm going to stop at this point, okay? So basically we learned the 3 main tools we need to perform electronic distribution. Periodic table to give us the number of protons which equals to the number of electrons for a neutral atom. Pauling energy distribution diagram, it tells us the energy of orbitals, okay? And then in such you should try to put electrons in the least energetic orbital available. And then we saw Hunds rule, okay? So the electrons in a set of orbitals with the same energy, the electrons should be placed as unpaired as possible. Thanks for watching. Pay attention to the next videos that will come.